Hello, everyone, and thank you for joining us on today's Senza Fili Sparring Partners webinar, The New Look of Drive Testing in 5G Networks. Our webinar today is sponsored by Infovista. Our speakers are Dr. Irina Cotanis, Technology Director at Infovista, Jaana Tengman, Director of Product Management at Infovista, and Monica Paolini, Principal at Senza Fili. I'm Kendra Chamberlain, and I will be moderating our webinar today. In Sparring Partners webinars, we watch our debaters discuss a topic live on video. We would like to encourage our audience to participate in the conversation. Please share your comments and questions through the Q&A button at the bottom of the Zoom screen. All comments are visible to all participants, so please keep the conversation polite and respectful. Our speakers will do their best to address questions as they go along, as they become relevant to the topics being discussed. So don't hold your questions until the end. And finally, please do not use the chat function, as tempting as it might be. Feel free to pop your comments into the Q&A though, so that our panelists can see them. And with that, I'll hand it over to Monica.
Andres, thank you so much, and thank you for signing in. It's a pleasure to be here, and it's a pleasure to talk today about drive testing in 5G. This is a continuation, a sort of follow-up on Sparring Partners that we had in December with Regis Vervoer, where we talked about the role of crowdsourcing. So today we're going to move a step forward and go a little bit deeper in terms of what do we need in order to test networks that are becoming more complex, where there is more to test and more opportunity to optimize the networks. And so the question is, how do we go about it? And I have with me Irina and Jaana at Infovista to talk about this. So let's get started right away. And I would like to ask both Jaana and Irina, what is the role, how is it they got into testing in the first place, and then we will go and dive deep in the drive testing, the role of drive testing in 5G. Irina, do you wanna get started?
Yeah, thank you everybody for joining. Thank you, Monica, for having us here to have this nice chat. I believe it will be a nice chat, interesting chat. So my background is in wireless communication, and I have been teaching for a few years in academia, but then I said, okay, I think my call is going into industry and not necessarily designing the network, but how in the world are you going to test the network and testing this more and more attractive things that the networks are going to bring us, and what are the challenges of testing. So basically, this is how I ran into network testing and then ended up as a technology director at Infovista.
That's excellent. You know, testing is actually it's one of those things that is getting more and more interesting because there's so much more to do. You know, so there is it's something that I got in relatively recently, but I have to say it's a really fascinating topic as far as I'm concerned. Jaana, what about you?
Yeah, I started out actually as a software developer, a young person, long time ago, and I was very interested in user interface design, and realized quickly that in the area of network testing there is work to do. So I actually started out very early in the early Gs. Working with network testing since. So I actually been with a TEMS team, network testing team, for more than 20 years. So my role today is working as director of the product management. So I have the opportunity to see all the nice innovations and everything happening out there. So it's a really rewarding and challenging work.
Yeah, it is. So since both of you have been doing this for so long, you know, when you think about drive testing, it sounds a little bit like an old school thing. You know, we've been doing it for so long. We still need it. It requires a lot of effort, a lot of work. Why do we need it today? So maybe you can give us a little bit about sort of historical perspective, where we're coming from, where we're going.
So we started to get more and more this question, why drive testing? And as you said, we have done it for all the Gs until now, and it can become quite troublesome for operators to spend a lot of money to do this drive testing because it's kind of expensive, right? And with 5G also, people are thinking that there are other aspects that will, like intelligence, come back to that immediately, that will solve the problem. Why in the world still to do drive testing? But let's think a little bit about it. First of all, we have to understand that 5G is the very first G that comes with the user at the core of it. Until now, all the networks, all the Gs have been decided quality of services, not quality of experience and the user. So the user is the centerpiece of it. The user means that it is the device itself at the core of the solving the problem. So the device is always, the user and the device are the core of it. And this can be done only with drive testing. Now, you are going to say, okay, but you have in the network a lot of machine learning developed in the net, at least how CGPP will evolve. Intelligence embedded in the net, in the nodes of the network, including the device. Why would I need still drive testing? Because I have the intelligence embedded already. Well, the answer is that none of these algorithms are standardized. Every single network vendor or device vendor will have their own algorithms that will perform different in different conditions and using different services. How are you going to test this? Again, you go back to the concept of drive testing. You have to drive test this in order to understand the performance. But then is another thing that actually it comes only with 5G. The fact that the device is very much a challenge because it's about the battery life, it's about the memory storage, it's about the spectrum. Now we have multi-band. We have like from very low band up to gigahertz, hundreds of tens of gigahertz spectrum. And not only this, but the bandwidths are hundreds of megahertz. All these from the hardware point of the device, it's very challenging. You may run into interference problems. You may run into overheating problems. Then another important thing is that 5G is three-dimensional. It's a massive MIMO system relying on 3D beamforming, and algorithms are designed in the device in order to coordinate these beams and to ensure the beam management. But then, unless you are on the device side, you can't actually know exactly why it happened and in the specific way. So then you are going to say, okay, but wait a minute, we are developing minimizing drive testing data. Why still drive testing? Well, true, and it will be there, but this new data source means a lot of signaling, exchange of signaling between the device and the network. It means a lot of, it can be triggered only in specific conditions. Maybe you want to trigger it when actually you don't have users in that area. There are a lot of challenges that are coming with drive test data, with minimizing drive test data source. So how you cope with this, with different scenarios, different multi-vendor, it needs to be, MDT is not multi-vendor, and you get by drive testing, both idle and active connected mode, as well as multi-vendor. And last but not least, I would say even SON itself, the concept of SON or self-optimizing networks, or the RIC controller, radio intelligence controller, which is coming with Open RAN, is the same thing. Those algorithms are designed, are proprietary design. How you evaluate them, you really have to do the drive test in order to understand what the user perceives. You are going, okay, sorry, go ahead.
No, go ahead, go ahead.
I was saying, okay, but you are going to say, okay, but are you going to do it exactly in the same way what you did it until now, spending a lot of money and time? Well, the answer is no. You really have to take at least three main approaches: automation, intelligence, ML&I, and generic testing.
Yeah, and I think that's where we need to talk more about, because the picture that you're painting here, it's a little bit almost scary, because it's like it's getting worse in terms of what you need, how much you need to test. So it is not true that with 5G you have less testing to do. You have more testing to do because you have more things that you can test and you can optimize. So there is more of a scope for improvement, but in order to get that improvement, you have to do the work. So compared to, say, a 3G or 4G network, you have more work to do. So the question is that how can we do more work without breaking the bank? And maybe, Jaana, you can tell us, so how can we do it in a way that we still can do it, but we're not going to make our life harder?
Yes, Irina said there are a couple of things to consider, and one is of course the automation topic. And with automation, usually, I mean, when we talk about that, it's very much about remote control and automatic file uploads, which is a bit old school actually. And as I said, I was actually a part of the team on basically when we invented drive testing a long time ago, and there has been very little change in how you obtain the measurements. You're still out there walking, driving, and then you're analyzing, and it's very much a manual process. And also the other thing that is quite manual is not only that you collect the data, but also deciding where to collect and what to collect and all these things. So from our perspective, what we had to do is, based on all the challenges that Irina brings forward, we had to really rethink this. We have to do this differently. So when we talk about automation, we take it all the way, not only from how do you get hold of the data, but who is collecting the data. This has previously been done by tech-savvy people, RF engineers typically being out there fighting against the storm and the wind and doing all these things. So what we would like to do is to bring those really skilled people to be more working on perhaps supervision or defining the tests, but be able to have very good and automated solutions that can out in the field do the collection and basically be carried around, either by a tester or by a drone or whatever that can collect data. So there has to be automation done both in defining the tests and then also in the actual instructions to the user. So there are many ways to make this much easier than what it has been before, and to change it significantly.
So we still need drive testing, but drive testing is a new thing. It's a new way, you do it in a new way. So it's like, we still need the sort of conceptually it's the same thing, but the way it is done has to change.
As Irina said, you will need the data, but the difference is how you get hold of it. So many of our customers that we work with, and when we look into how this is done, if we think of how do I decide what data to collect? Today, this is quite a manual. It's a discussion. It's perhaps reports you look at and you identify problem areas, or you have a site that is deployed, or you have a new feature that you want to evaluate. And in order to do this, it's sort of, okay, let's have a meeting. Who is going to do what? And let's set up a lot of test scripts. What we think of as more of a data-driven process. For example, when a site is set up, the information regarding this is pushed through the system and request a drive test or request a test, rather than just, okay, who should do what? So the structure of requesting a drive test from any type of data source is, of course, one of the things we need to look into. But the other thing is also for the end user then, or the tester, that, okay, I've never done this before. How should I do it? So one of the things we're discussing is, if I were asking my mother or my father to do the test, who is in a completely different business, how and what do they need in order to actually obtain the right data? So not only do they need to know, they don't care about if it's RF or whatever, they just want to carry the device. So the instruction to the user has to be very straightforward, like go to this place, stay there until the test is done. And the application itself handles all these complicated things of looking on bands, frequencies, what tests to run, should I do a data upload, should I make a voice call? All these things are completely out of the, how should I say, the view of the user. It's happening automatically based on the sort of already defined test case. And then the result is, of course, we talk about post-processing in our area, and I think the era of post-processing is sort of going towards instance processing instead, or instant evaluation. So not only is the application evaluating if enough data is collected and the correct tests are done, but it is also feeding the information back to the system that requested it, basically, whether it's a person or if it's some other solution. So for the tester, basically, to carry the test equipment around to the right place, that's the only thing they need to care about. All the other things are abstracted and handled by the application.
Okay, so there is a lot of different phases here. So it's like from the, from collecting the data to using the data to predict network performance and things like that. So, but before we can go and talk about all the different phases and how automation can help, there is the other element that Irina mentioned before, which is AI and machine learning. So maybe, Irina, can you give us like a general view of what is the role of AI and ML, and then we can go deeper into the different phases and how is it changing. So, Irina, can you tell us, what's, because if you have just automation, you still kind of have the problem. I mean, all this data that you collected, and what do you do with it? You're overwhelmed by the amount that you have. How can you get what is relevant from there?
Yeah, so of all the automation that Jaana talked about, actually, you can call it automation, but as she mentioned, it's a lot of intelligence embedded in order for that regular user to do the drive test for you and to get the data and what data to get. So first of all, you have, during the process of collecting the data and this entire process of automation, there is a lot of intelligence behind it. Then when it's about machine learning, the evolution of drive testing is also it needs to happen in the way that the probes themselves are more intelligent. And when I say this, I say that the probes need to be intelligent going towards more predictive. So you would be able to predict, at least in short term only, a specific behavior or specific performance. And a good example could be the connected car use case in which you would like to know, okay, I am going out of the coverage area, what I'm going to do now, for example, or I am going to lose my connection for the map viewing because the throughput it's gone, and all these kind of things preemptive. Also, intelligence on the probes means that I can do to a small extent, I can do already kind of a root cause analysis in real time, near real time. It can't be a lot of information because it's kind of short term, but still you can flag specific things that can direct you, okay, then you should look at these points for this specific problem. The other thing where machine learning works in drive testing is the fact that, as Jaana mentioned, it won't be anymore about the post-processing, having a huge tool doing this, collecting, having all this data processed. It will be very much machine learning based. So basically we run through a lot of files based on using specific algorithms that will detect trends, anomalies, all these kind of things that need to be done automatically as well. But you see, you cannot separate automation from machine learning. They are all together. And then machine learning in drive testing is also under the cover of the QoE modeling, quality of experience modeling, because people know already we have for voice, we have for video, we are looking forward for gaming, but all these have been developed in a traditional way in the so-called deterministic models. This won't work anymore in the 5G. Why? Because the network is more and more complex, and the interdependency between all the network elements cannot be described anymore with a simple equation. Even simple equation, no, so it's not a simple equation, but it's more or less a deterministic way. But machine learning is the only one that can see what humans cannot see. And these interdependencies are better described. And we in Infovista did this for voice and working also on video and gaming as well. And last but not least, you have heard from Regis already about ML in planning, right? Once you have the ML, planning needs to rely on ML as much as possible, and the value that Regis unveiled to you in the need of it. So these are kind of the places when ML really needs to be in order for drive testing to evolve or to be revolutionized, actually.
Yeah, so we have both automation, AI, and ML working together across, sort of like in parallel, throughout all the stages. So why don't we start from where is and when you're gonna test? So that's kind of the first point. So who wants to go?
and I mean, as I said previously, where you test or today, I mean, it is traditionally perhaps more of a manual decision rather than a data-driven decision. So there are many cases we can describe, but from our perspective, what we say is that there should be a data-driven process that also includes not only where to go, because this is, I mean, you can say, okay, let's go this route. How do you optimize this driving? There are different tools to do that, of course, to make it fast. If you're thinking driving, I mean, you can get drive instructions. But the key here is also to make sure that you collect the data you really need, not only go there and test because that was an easy thing, that is the fastest route. If you don't collect what you need, then it's still useless. So from working with benchmarking, for example, we have learned a lot about what the importance of actually collecting the data you really need. So besides telling or getting the instructions on where is the test needed, also what data is needed in order for this test to be fulfilled. So when you have these things, previously this was evaluated by the tester. Do I have enough voice calls, or have I measured in the right place for the right KPI that I'm looking for in order to solve my problem? Or so this is all, for us, this is now an automated process. So we get these instructions on where to drive. It could be triggered from as I said, a site data file, or it could be triggered from a drive route or from a request for a test, basically anything. You perhaps have a customer complaint that you would like to have more information about. Is it really true that their gaming experience is bad? Is it a network depending thing? We can do a interactivity test. But when you have this, the directions, you know what you need in order to fulfill your test, it becomes much quicker because you will not spend any time driving around or trying to collect data that you already have, and you will not go back home without having the right data. So regardless if you're an engineer or if you are a tester, this will of course help you to shorten the time to results significantly. And for us, this is really a critical point to have the definition of done. When can I go back home, basically, or when can I take on next assignment, as well as how do I get there? And when we talk of how do I get there, it has been very much, okay, let's drive there. What we also do and what we have looked into is several different ways of predicting the best way of obtaining your results. It could, of course, be for a benchmarking test that you should drive certain areas because it's within your request, but it could also be, as example, in site verification, that you want to test in a sweet spot or so. So we can either use planning information to predict this, where the best spot should be, or we can also do auto scouting within the tool to tell you that, hey, stop here because here is the best spot to do your test. So these things are really important, that you do not rely on that the tester knows that, okay, this should be a good spot, looking around saying, do I have a line of sight and things like that, but that you have a data-driven place to, so it's data-driven where you should go. It should not be like an ad hoc happening.
So basically you have a feed loop, and that's where you need to have automation and AI to basically, instead of having a big master plan that you have to execute and then you go home, you just keep going, and then you keep collecting data where you need it, but if you don't need it, you don't.
Exactly.
And so it
And
just keeps you auto-refine as you go along, right?
So don't stay somewhere and test just because it's fun. Or you could do, but that is not correct. No, but the key here is to shorten the time to result, because it is not only, of course, time consuming to do the wrong thing, but it also takes time before you get perhaps the acceptance or the error solution, the auto healing or whatever you're looking for. You need to have the result as fast as possible. And for that, you have to be as precise as possible when it comes to where you should go and really to the point. So that is really key. And then as a user, it is very tricky to do this in real time. It is easy if you only are looking at, can I send my text message, as you could do in 2G or so. But now there are many services, there are many things to verify when you go out on these kind of data collection activities. And it is very tricky to verify all this just by looking at it. It's almost impossible to display or show this. So therefore, of course, the machine, the computer or the device, the phone, the application should assist you with this. So we think we are very high tech in telecoms, but actually we are not more high tech than most others. So I think it's really time to start harvesting the power of the machines also in telecoms.
Yeah, absolutely. So let's go one step further here. So that we are in one location. We don't need to do some drive testing in one location at a special time, as an event time. So you're there, and but you can be testing different things. So there is place and time, and what is that you test for? And maybe you can tell me, because you mentioned complexity, and you can test for devices, services. So what is the depth that you want to go into?
I think, I mean, just to very quickly, I think it depends a bit on the use case, because it depending on what kind of result. If you, for example, if you say that it is, let's compare different operators, you would not go into troubleshooting details on competitors, for example. That doesn't make sense because you don't want to fix their networks. So then you can keep a quite high level. Perhaps you have more of a KPI, number of calls, success, and so on. But if you are troubleshooting, of course, you would like to have the deepest detail on the problem you're troubleshooting. And the good thing is that as we have been doing these types of tests for so many years, we can basically, we know how to go to the deepest level and also to stay on a high level. So you can decide already when the test is set up, so to say. It's also decided based on the use case, what level of data you should collect. And I think, Irina, you might want to comment on this as well.
Yeah, so exactly what Jaana said. So not all your test use cases will need all the data. And generally, until now, everybody collected all the data, but you would need kind of, your test scripts will have kind of a log mass getting out only the KPIs that will actually solve that specific use case. That you have to be really laser focused. What is my problem? What use case do I need to solve? And it's also a lot of learning to develop these kind of things that we are talking about. It's actually based on a lot of experience and learning process, and sometimes even using machine learning or a large amount of data and developing things. What is the data that is valuable for that specific use case?
Yeah, so by the way, everybody in the audience, if you have questions, ask them now, because we're not going to have a Q&A at the end. We just get questions as we go along. So, you know, feel free to send us questions. You see that you're kind of shy today. We usually have the opposite problem. But anyway, can you give us some examples about what kind of use cases an operator might be looking at?
So the use cases that you are looking at, it's about the benchmarking and the troubleshooting of the network, but it's also very much focused towards the services that you are going to test. So a lot of use cases will emerge from testing the services. And now here comes the challenge. We all know that 5G comes with huge opportunities for business opportunities, actually, right? We open it to IoT verticals as well, and it's very tempting, but nothing, there is no free lunch in the, it is what it is. This is life. It's no free lunch, because in order to provide this, you really need to have complex networks, which you would like to support for every single service that's there with minimum costs, right? How are you going to do that? So speaking about the variety of services, when I'm speaking about varieties for every single type of application, OTT application, just to give you an example, you have a variety of them. When it's about gaming, the same thing for different games. And it's not only that the variety, but it's also the solutions, their platforms, the clients, the codecs that have been used. And also each of these have different encryption levels. I can access some information, or I can access no information. It depends how encrypted that application is. And then you are going to, okay, and what is the, how are you going to test this? Therefore, the trend, the shift within, regarding drive testing is towards going generic testing. So instead of testing every single service, you will test traffic patterns that emulate a class of services. For example, we are talking about gaming. You can emulate traffic patterns for a specific gaming genre, like, I don't know, like a first-time shooter, or the most attractive ones that somebody will play on the mobiles. And then doing the measure, so you don't depend anymore on every single service. You have this traffic pattern, and then you can do measurements, the KPIs information that you collect on this. And then based on this, you can build the figure of merit of the performance of the service. And for example, the most important services that will literally request this kind of testing, emulating testing, is the low latency services, like I mentioned, the gaming, for example, right? Or video conferencing, or remote drone control. This will require a lot of the interactivity. So basically, I want to build a figure of merit of the performance of this. And this actually is done interactive, we call it interactivity scoring. So it's built based on the KPIs in the network. But now, likely you are going to ask me, well, but it's not the real service. How can I trust this? Why is this, you keep saying it's meaningful? Well, there are 2 points to this. First is that you don't develop this out of the blue. You have to analyze the real world. So it's the process of coming up with this kind of generic traffic patterns requires a lot of research, real life testing of the real services, and then you say, okay, this is the traffic that the best describes the behavior of the service. Secondly, is the fact that I talked about the figure of merit, like the interactivity score for low latency services. This cannot be designed again out of the blue. It requires some testing, subjective testing, in order to see actually what would the subject say regarding the interactivity based on this kind of conditions. This is done before, so this research needs to be done, and afterwards you can have it in the product and you can run safely. Why you can say run safely? Because what the scope for operators will be, am I meeting the minimum performance requirements? Is my link good enough for this category of services? Because I deliver services in specific areas. I might not need in specific areas performance that will deal with high demanding gaming, right? or remote on control, and then this changes, and then I can kind of have templates of performances depending on the service that I would like to support. So this generic can help us a lot to kind of make testing more pragmatic, faster, still having the real information in it. And also generic will be, the other of generic is the fact that you won't need to emulate, especially for voice services, when you are talking about the client, and also video streaming services with the client itself. Again, you won't need to have client for Netflix, YouTube, or WhatsApp, or whatever. You build a generic behavior based on lesson learned and a lot of experience, and then you can quantify what would be a user perception of a specific service that you are testing.
Yeah, and so you can sort of target your tests in a way so that you can capture user experience without having to ask, the user, how does it work, indirectly, and for different types of services. This way you get all the detail you need. And we have two questions from the audience. And so the first one is from Vipul. Do existing testing apps like OpenSignal have the characteristics of collecting focus data for specific troubleshooting use cases? And if yes, is the data collected sufficient for RCA? And I think here, this is there's a more general question, I think, built in here is, can operators just use an app to do this? And what's the difference? Which I guess goes to the point of like, well, why do we need drive testing anyway, right?
Yeah, actually goes to the topic of crowdsourcing.
Yes, yeah.
It's a crowdsourcing. And the right answer is that actually crowdsourcing and drive testing are complementing each other. It's not like one or the other. So OpenSignal. Yes, OpenSignal collects a lot of user data, but it's only in the connected mode. So it's if the user uses that service. If it doesn't use that service, it is what it is. That's one. Secondly, it's where the services are. So if I am in an area and I cannot actually troubleshoot something if in that particular area I don't have users using the service in that area, not let alone the fact that I might not have even service. While with my drive test, I can, in idle mode, I can detect actually there is no coverage here, also, even if you are doing benchmarking, because honestly, crowdsourcing also in for benchmarking, and there is an ITU recommendation E812 doing this, but there are a lot of constraints because you have to support people are saying statistical significance. Well, yes, but it's not about the statistical significance, it's about the geographical significance of the problem, because I need to cover the entire area. What is very good crowdsourcing on, it's I determine the hotspots. I know that I have to develop there more and more, and to extend the network, and also to the traffic models that you heard from Regis a couple of in December timeframe, right? He told you actually how we work with crowdsourcing to deploy these planning models. But with drive testing, you actually, not only that you test where actually really the problem is, which something that your crowdsource cannot see, but the level of depth, because I think the question was if I can do root cause analysis with OpenSignal data. Well, you can just to a certain extent, because you still get some RF information, but it's not good enough in order to troubleshoot or do root cause analysis. It's never good enough. One. Secondly, it may work on some devices, but not on all devices. Because if we speak of iPhone, everybody knows it's everything, it's right. How I'm going to, iPhone doesn't have in-depth information regarding RF at all. Some devices provide some, but not good enough for a root cause analysis. But again, don't exclude crowdsourcing because it's out there and it's very helpful.
Yeah, and also with crowdsourcing, you can see data from other networks, which is interesting. But on the other hand, you want to go deeper into your network, which you can do with drive testing. So there is a question between breadth and depth. And I guess the integration of the two allow you to put the results that the other method gives you in perspective.
Yeah.
So and you can also think of crowdsourcing as one of the inputs on where should I do more drive testing.
Yes.
Because if you're interested in a specific service, how it behaves, it might be that it's not even launched or you have too few users in order to see if your network is ready. And as Irina said, it can be device dependent and you might not have enough users using that type of devices so that you can actually form yourself an idea or the service that you're thinking of. So the difference is, I think you can see crowdsourcing as an indicator, but you would most likely have to go into deeper level. And well, if you have no users, no service, then it's very hard to do activities. But you can use the heat map you get to say, okay, if I'm looking into new services, I should probably focus my drive test area, the verification area in this and that area. So you can use it to make data-driven decisions on where to do your drive testing, definitely.
Yeah, absolutely. And so they need to be integrated. Now, there is another question, which I think is kind of somewhat related to this, which is about to talk about the possibilities of positioning and localization service measurement. And I think that, again, this brings another question with it, which is, well, sometimes you can drive into buildings. So we need to have a different way to think about that. So, but maybe let's talk about positioning and localization service measurement. How do you deal with that?
I think this is really where drive testing excels, because you do have the GPS position basically everywhere where you are outdoors. And if you go indoors, you use something called pinpointing, where you tell either automatically by scanning the floors and the boards, the floor and the walls where you're going, or you can manually sort of leave a breadcrumb trail exactly where you're doing the test. So I think the positioning with drive testing, walk testing equipment is one of the strengths when it comes to troubleshooting. I don't know if you want to add anything on that, Irina, but you can also use it to verify positioning from other data sources that you get. I mean, from MDT and so on, verify that you actually have the right positioning. So yeah, so I don't know, Irina, if you want to.
No, I think you covered very well. So basically, drive testing is the key for getting the GPS location. So you cannot get better than this.
Now, there is another dimension though here, because we talk about drive testing, but it could also have a situation where you're actually not driving. So you could be, using something like a drone or something else.
Yeah, you can do walk with it.
There's a new way, like, less old school, like it's not just a car. You don't have to be in a car, or you don't need to be in the having the usual car setup.
No, and I think that is when we go back to the automation discussion, that today we expect that everything is carried by someone that knows how to operate it. But we can, of course, also do measurements where you place this in a drone and the instructions on where to go to obtain the information is fed to the drone control solution. So that's one thing to think of it. Or it could be someone walking, or it could even be stationary testing if you feel that you have areas where you really want to have this detailed service analysis of the data that you collect. So definitely there are multiple different ways. You can also, we look into the future and see that, well, basically anyone could be a tester. And today we are also working a lot with devices that are not really designated, expensive, special devices. It's very much commercial off-the-shelf devices that can operate with high accuracy in order to obtain these measurements. So that means that you could have like an Uber driver or someone collecting the data for you. So instead of ordering yourself a drive from home to the cinema, you would ask for a drive test, and someone could just pick it up and make sure to deliver it, basically.
So how is that different from crowdsourcing?
There it would be really tricky for you to tell. I mean, then you can of course have to use. You would not be in control of where they are going. You just hope that they took the route you wanted at the same time you wanted, and that they were using the services you like them to use at that time. So I think that is one of the major differences, that if you really want to have control, you design the test. The test is already preset, and it's just carried around by someone, a drone or whatever, that collects the data.
Yeah. So basically, it's not crowdsourcing, because as I say, with crowdsourcing you can't control where people go.
No, and you cannot control what they're doing
or what they're measuring. So you can basically remotely, if you have the Uber car going around and testing, you can still control, like what services, what kind of. So you just basically have. It's just you don't need to have a person on the ground just doing that specifically. I mean, just somebody that the operator, an operator, employee, or contractor. Okay, we have another question, and this is about. So this is from Abdullah, and it's if I want to check the signal quality in a certain area, does that will give different signal levels for each service type and different beamforming scenarios? And I'm not quite sure I understand the question here, but I think it's maybe.
I think that the question refers to the fact that I said generic testing rather than the service itself. And the question may come up because of saying, okay, but if it's not the service, how can I make the network? Because this is the network. When a service is set up, the network itself allocates specific resources in order to support that service. And I think refers to the fact that, oh, okay, but if you just have traffic patterns, then those might not trigger specific resources or specific beamforming configurations. The answer is that exactly that's why we do a lot of research before having it implemented in the tools. We do analyze a lot of traffic pattern to be as close as possible to make sure that the resources are allocated exactly when, like it would have done in a real scenario of a real service application. So the secret sauce come in designing these traffic patterns, which is a research before having it in. So yeah, but it won't work if you just have a simple thing. Then obviously the network won't trigger exactly the resources you would like to, and then your signal strength information won't give you the same information that will do if it would have been the real service.
Now, yeah, you mentioned doing drive testing for fixed. In a fixed scenario, and that brought to my mind the issue of IoT devices. We're going to have more and more IoT services. Do we need to drive test for them, or don't we, since they're not moving? And most of them, sorry, I shouldn't say, but or how do we think about doing IoT testing in general?
I think first of all, you would at least want to know that the network is working for the services the IoT devices are supposed to use. So yes, you would like to test it. And here is also where you might have a tricky thing, because there might be not many other data sources available. So then if you continuously have to monitor them, you can take the, for example, if you think of IoT devices as remote controlled vehicles, for example, you would most likely want to monitor that those have the radio resources or the bandwidth or whatever is required in order to operate. And if things goes wrong, you would like to either predict that they are supposed to go wrong or what exactly happened. And therefore, you would most likely want to do also deep level data collection on these types of IoT devices. So yes, I think that it might not be in the same way that you order them to go to different places, but more from a monitoring perspective once you have deployed it. I don't know, Irina, if you want like to elaborate, but I know that, for example, the traffic patterns of the different services, it is very similar. It's not a similar, they will not be gaming, but you will still need traffic patterns, for example, for camera control and things like that. So those things needs to be tested also in the future.
Yeah. Now, we talked a lot about collecting the data, where to collect, what you use, and things like that. Now, let's think a little bit about what do you do with that data? How do you use it? How much do you need to save it? How can you make sure you don't get completely overwhelmed by so much data you don't know what to do? And what's the best way to use it to improve the network, to predict, to help you predict potential issues and things like that?
Okay, but you see, this is actually what we do with, we plan to do with our solution, because as you remember, we said you drive where is needed, when is needed. So you won't get and collect the data that you would need. So your use cases need to be in such a way that this is how we define in the use cases. The use case comes from a problem, and I know the problem, and I know the data that I need to collect, and I process only that amount of data. It's faster, it can be quite accurate, so you don't need to get a lot, give me all the data in the world, and then I am going to go through it and figure out what's going on. I am going very precise in specific areas with the problem defined. This is how I actually, and I think this comes to, you have also on a question, somebody asked if MDT and cold traces triangulation is going. So the question is, MDT and cold trace triangulation is going to be more accurate and mature as better 3GPP guidance standardization comes along. Do you think drive testing will be still relevant? Well, the answer, if you think of drive testing as it was even with 4G, no. But the way we talk here about drive testing revolutionizes drive testing with the way we are talking about being very focused, laser focused to the problem that I want to fix and complement the information that the piece of information that I'm missing. The answer is yes. And let me explain. I touched upon a little bit on minimizing drive test data. That's true. That data is geolocated. That's perfectly true. But that MDT it needs to be triggered. It can be triggered in the immediate way or logged way. So this needs to be coordinated in the network. And luckily, you may get the data that you want to, but there might be gaps. When you have the gaps, your precise laser focused drive test will go there and collect exactly the piece of information that you are missing. So you would get this information. That's first. Second, MDT stays at RAN level. You won't know exactly what is the user perception of anything. It's literally coverage specific, while drive test completes it with the impact, okay, what is the upper layer or application user centric. Now, when it's about cold traces, yes, hopefully triangulation will help cold traces a lot, yes. It's still a long shot to go, but of course everybody hopes for the perfection. But with cold traces, you will never know. You will know the MZ, so you will know the device, but you won't have the service identified. So and it's also only in connected mode. Again, you are missing the pieces of the idle mode. That is very important because the device itself and your user perception is connected very much with what happened when I am accessing the network. That period of idle determines what will happen in my connected mode. And the only piece that brings this information is drive testing. So cold traces miss this information. And also I don't know from cold traces what kind of service it was. So here can complement it. But again, not the drive testing that you imagine. I sit in and I drive, I have to drive 100 miles around the city and forget about it. It's not going to work. But this laser focus drive testing with use cases, problem, when, where, and how much, and also the whole automated process that you have your field engineer is not an engineer, it's a technician who doesn't know much, or can be on the drone that is fully controlled from the back end.
And we have what I've sent a link to all of you on a blog that Irina wrote about this. This is a very interesting blog, and I also posted the link to the Sparring Partners that we did with Regis Larbour in December, and an article that I wrote on that. Now we have another question here, which I think is more for Jaana, and it's about the cost device measurement examples you mentioned, for instance, the Uber example. I was very interesting. And how would one approach calibration of measurements obtained for such devices, given the uncertainty of measurement introduced in the post-processing from COTS devices? Which I guess is something that we also talk with Regis about in terms of, you know, when you do testing that you do not have 100% control, or that, you know, there is a lot of variability. How do you make sure you have the data is not biased effectively, right? Yeah. You need to remove the bias, get what you need.
And this is the beauty of drive testing, because the difference is when you do crowdsourcing, anyone can contribute. But in drive testing, you decide that this is the actual test that should be run, and it should be run in this area by this tester. So even though the tester is an Uber driver, you would define that this test is suitable for this type of device. It might be because not all devices has the performance you want in order to perform a certain service. If you are doing 5G services, 5G testing of high speed, and the Uber driver has a 4G device, he couldn't be able to sign up for the test because it wouldn't work for you. So when we talk about off-the-shelf devices, what we mean is that it's still a controlled device. It is not, you should not use, you should, how should I say, it is very important that you use the right device for the right test, and you should be in control. The one ordering the test should define, okay, this is the needed capacity of the device that I need in order to obtain the test. So therefore, once the data is collected, it will be with the right device. Of course, there are things like, we talk a lot about this, for example, thermal mitigation. If the phone gets really hot, it stops performing in the same way. So one of the things that we, of course, need to inform the tester, as I said in this automated test, is that, hey, your device is too warm. You have to cool it down before you can proceed, because we will not accept your measurements. So these things will also be, or these things are also already built into the automation part, that you verify the measurements and you verify that the right device is doing the right types of tests.
Yeah. So it's kind of
I hope that answers sort of the question. But that doesn't mean that you cannot use your normal smartphone. I'm trying to show my smartphone here that you can use that for doing the test. But it might mean that Irina's smartphone is deemed too old, so she will not be part of the test team.
To be rejected.
So you still, I would at least, for a foreseeable future, I would recommend, or I would think that most of these guys and girls will be, to some they will, or everyone will be signing up for doing tests, and by that you will also know what devices they are carrying, and you can pick and choose the right test for the right device.
Now, we don't have much time left, but before we go, the question is that, you know, we talked about all the new approach and everything, but at the end of the day, a key concern for an operator is to keep costs down. So can they keep costs down with this? Is this an approach that's going to cost an arm and a leg, or can they contain the cost? What's going on here in terms of the cost?
I think, first of all, you have to be if you take a data-driven approach, if you use the strength of AI ML, and if you go for this generic testing, I think you are very well positioned. So yes, definitely you can keep the cost down. But if you continue thinking about 5G testing in the same way as you did for 3G and 4G, you will probably be very stressed out. So that is at least our view of it. So we invented drive testing, and we are changing drive testing. That's basically our thought, and I think that is also what what everyone doing this also are thinking at the moment. So
yeah,
I
and so
don't,
is it like so everything is become as a service? Is this going to be something that operators can use as a service rather than purchasing the tool or the solution?
I mean, looking into the future, yes, definitely there will be different ways of doing this. I mean, owning things, renting things, having as a service, everything will be possible. And it might even be that you don't even think of testers as testers. Perhaps we gamify everything, and you sign up for being saving the world and testing some e-gaming. I don't know. It's very different. I think we will look at different business models as well in how you work with testing.
Absolutely. We are at the top of the hour. It was a great conversation, and there's a lot of more topics that we can go into, but it's going to be for the next time. And you will eventually, actually very soon, be able to also read the conversation, so you can go back to it. And so thank you all, Jaana, Irina, and everybody in the audience. And Kendra, back to you.
Okay, thanks, Monica. That will conclude our webinar for today. Thank you again to our speakers, and thank you to Infovista for sponsoring the webinar. A recorded version will be available on the senzafili.com website in the coming days. Thanks again, and we look forward to seeing you at future events.